filmed in front of a live studio audience. No, I'm just kidding. All right, so let's take a look at this. Nomenclature. So in this chapter, we're gonna learn about how to name chemicals, chemical formulas and all that kind of stuff. It's gonna feel a lot like you're in a foreign language class, like legit like Spanish, because we're gonna conjugate things, things are gonna have different endings, all that kind of stuff. But it's not challenging because one, it's only one chapter, and we start at the beginning and we kind of go through all the rules. And I even show you at the end how to kind of have a guide that has all the rules on a very small piece of paper, so you have one thing to focus on when you're studying with it. The biggest thing that you can do ahead of time, though, is memorize those elements in polyatomic ions. Okay, so ions are charged species formed from the loss or gain of electrons. So here we have a species, and like chemists like to, use the word species to represent elements and whatnot, even though it doesn't feel like it's a dog or something. But they want to be included. So they have sodium, all right, and when sodium loses an electron, it becomes positive. So it'll become +1, and that's now our ion, all right? And there's certain names for positive ions, there's certain names for negative ions, and we're gonna go through why sodium only becomes +1 and it doesn't become +2 in this as well. All right, so let's talk about positive ions first, and they're called cations. So we have ions with a positive charge. How do they form? Well, they form when an atom loses an electron. Now, when an atom loses an electron, its charge is normally neutral. When it loses that electron, it becomes more positive. And this is my word explanation, which we're going to go over, and then I'll draw it to show you as well. All right. So first off, you don't need to write this down. All right. There's no space for you to write this down. Don't worry about writing this down. This is just kind of like a let's think about it kind of a thing. The only thing you need to know is up here. So sodium has 11 protons. So I'm going to say it's 11 plus because protons are positively charged, and 11 electrons. So that'll be 11 with a minus. All right. 11 electrons, and it'll lose an electron, which we're going to talk about in a second. So if you think of protons as +11 and electrons as -10, since it lost one, let's see what happens here. So normally, sodium has 11 protons and 11 electrons. So when you add these two together, these charges together, it's like it goes nowhere, it's 0. You can think of it as on a number line. So if this is 0, and here's conveniently 11, and here's conveniently -11. So on a number line, let's say we go to 11, and then we go back -11, we're at 0, so nothing really happened. But now, if we only have 10 electrons, we have those 11 protons, and now we have 10 of the electrons. This would be +1 when we add it together, because now you're still going forward 11, but you're only going back 10, and that'll end you at 1 there. All right. So that's the first way that I'm going to explain how this works. The second way is drawing an actual atom. All right. So let's draw an actual atom of sodium. How many protons does sodium have again? 11. And how do you know that? Besides, I just told you. What could you look at? Right? The periodic table. So it's number 11. It's going to have 11 protons, so we'll draw them in there. 1, 2, 4, 5. 6, 7, 8, 9, 10, 11. And then it needs about how many neutrons? Yeah, 11 works too, right? So we can kind of draw them in between if we want to make it look more accurate. So there's 4, 5, 6, 7, 8, 9, 10, 11. That looks okay. And then let's draw some electrons. So there's our nucleus. How many electrons are in the first energy level? 2, right? And how many electrons do we total need for sodium? 11, right? Because it has to be the same as the number of protons. All right, so we can only put 2 in the first energy level. How many can we put in the second energy level? We can put 8, so 1, 2, 3, 4, 5, 6, 7, 8. So now we have a total of 2 and 8 electrons, so we have 10, right? How many more do we need? We just need 1. All right, so we have 1 more electron in there. And that's what sodium is, all right? Now, by looking at this, why does it make sense that sodium only loses 1 electron? You want to help us out? Yeah, Kira. Yeah, exactly. There's only 1 electron in the outer energy level, and if it was going to lose that, then it would have a completely filled outer energy level, right? It would be a lower energy level, but it would still be completely filled. And that's what all the atoms want to do. They want to have completely filled outer energy levels. So that's why sodium is just going to lose 1 electron, and it's going to become +1. Everything in sodium's group on the periodic table is going to do the same thing. So lithium, sodium, potassium, rubidium, they all have 1 valence electron. So they're all going to lose 1 and become +1. So everything in that group will be +1, all right? Now, let's say that we change this to magnesium. How can we change this to magnesium? We need to add what? We need to add a proton. We could add a neutron, but let's skip that for now. And then what else do we have to add? And 1 more electron, right? So I'll put it on the bottom there. So we have now 2 electrons in the outermost energy level. So how many electrons is magnesium going to lose? It's going to lose 2, right? It's going to lose both on the outer energy level. So it'll lose the top one and the bottom one. They'll be gone. And then it'll have a filled second energy level. And since it lost 2, magnesium will be +2. Everything in that group will do the same thing. So beryllium does the same thing. Magnesium, calcium, strontium, they all become +2, all right? So do you see this trend that happens with them? That's what happens throughout. Now, we're not going to look at this again until later on when we actually start drawing Lewis structures for things. But I just wanted to explain it in the beginning so that we know, why I'm telling you sodium's +1 and why magnesium's +2. It has to do with the energy levels. Okay, we're going to come back to chlorine because we're going to the anions. So anions are ions with a negative charge. And how do they form? They form by gaining electrons. If you have more electrons than protons, it's going to make it negatively charged. Same thing here. You don't have to write down this. This is just so we understand what's going on. Chlorine has 17 protons. So 17 plus 17 electrons. So normally it's neutral, all right? It's going to gain an electron. So let's rewrite it. So we now have 17 protons and it gained an electron, so it's 18. So now when we combine these, it's going to be -1, all right? So the electrons is -18 since it gained 1. Add those two numbers together and we get the overall charge, and that overall charge is -1 for chlorine, making it Cl -1. So it gained an electron. Let's find out why, all right? Back on this side, how many protons does chlorine have? Yeah, 17, great. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18, 17. Oh man, that's a lot. How many neutrons do you want to give it? Sounds good. 1, 2, 3, 4. 17, good. And how many electrons in total? Yeah, we're going to do 17 to start off. So 2 in the first energy level. That's a total of 2, so we're not at 17 yet, right? How many in the second energy level? Yeah, we're going to go with 8 because that's going to give us 8 on the second energy level and 2 on the first energy level, so that's 10. And then on the third energy level, how many are we going to have? 7. 1, 2, 3, 4, 5, 6, and then 7. All right, so we have 17 electrons there. Now, if you just didn't know anything else besides knowing that it wants to get to 8, how many electrons does it want to gain? Just wants to gain 1. So Cl is normally just Cl, but once it gains an extra electron, then it's going to become Cl -1, all right, because it has 17 protons, and then now it has 18 electrons, so when we add them together, we get a total of -1, all right? Now, where did it get that electron from? Could have gotten it from sodium, right? Because sodium wanted to give up 1, and then sodium wants to gain 1, all right? So that's kind of how this chapter is going to work. And we want to balance things out too. So if we have something with a +1, we're going to want to make it with something that's a -1, or we can do multiples of something to kind of make it balance out as well, which is where it gets a little complicated, but not bad. Okay, any questions with any of that? Okay, so last thing in this little section, we have ionic compounds. They're also known as salts. We put the cation and the anion together. So in our example that we just had, we had our cation was Na+, we have our anion, which is Cl-, and we're going to combine them together to make NaCl. All right? And for now, we're just going to label the periodic table with the charges so that you don't have to draw all the atoms and all the electrons and stuff that we just did. For this chapter, I don't want you to focus on that. So on our tiny periodic table, we're going to just label this with what each charge for each group is. So you guys already know this one. What's this one going to be? Plus what? Dylan. Yeah, they're all going to be +1. Because remember, they all have one valence electron, right? What about the second group? +2, we saw that because we did the magnesium example. And the other example we already did was chlorine, which is going to be -1 because it gains 1, right? Does anybody remember how many valence electrons oxygen has? It has 6. So it needs to gain 2. So when it gains 2, it's going to become -2. Nitrogen has 5, so it's going to gain 3. Carbon has 4, so it can gain or lose 4. And then boron only has 3 valence electrons, so it's going to lose them to become +3. So now we have most of the things filled in here. Noble gases are filled, so they either have 2 for helium or they have 8 for the rest. So they don't get a charge, so we kind of just put a 0 there. And then the transition metals, their charges can change. So I like to label it as +?. And also for the transition metals, we're going to have this little barrier here where we're going to include these as metals in this chapter. But we're not going to talk about those ones being negative this year. In AP Chemistry, they'll talk about what actually can happen. So we'll keep it a little bit simple for this. All right, so now we have our periodic table filled in. So now if I asked you, like, what does phosphorus become charge-wise? You'd say, oh, it's in this group, so it's going to be -3. All right, and that's all you need to know. You don't have to draw the atoms like we did for these ones here. All right, but if you drew them, that's how you'd figure it out. Okay, any questions with any of that?